Residuals. Okay, this is probably a fully new word to you, but residuals is basically, it's the residual equals your data, whatever data y value you have subtracted from that predicted y value. And remember that predicted y value is from that line of fit. So it's, to me, residuals make more sense when you look at it visually on a graph. So let me show you. So number one says construct a residual plot from line of best fit. But let me just kind of discuss what residuals look like visually. So like if I look at this first point up here in this upper left, this first point up here in this upper left, the residual is how far it is away from that best fit line. So like this would be a residual right here. That'd be the residual, this little blue line that I drew there. Okay. And the question is like, how far is that away from the line? Well, this is at 30.2 and the line's exactly at 30. This is a positive residual of 0.2. That's what that residual is. This residual is like literally on the line for this point here. This has a residual of 0. This one, the residual, how far is it from the line? This is 0. Let me erase that real fast. This is a positive 0.3 residual because it's 0.3 above the line. It's at 29.3 while the line is at 29. This point down here is at 28.6. The line's at 29. That's at 28.6. So that means there's a negative residual below the line of 0.4. It's 0.4 below the line. That's the residual there. Again, this one has a residual of 0 because it's on the line. But this point down here, that's at 28.2. And it looks like the line there, if you kind of scroll over here, is at 28.5. So if that's at 28.2, that means that this is at a negative 0.3 residual. Keep on going. This looks like it's 0.2 above. This is right on. This one looks like it's only a 0.1 because that would be at 27.5, that line, right? Here we have a 0. Whoops. And then this would be a negative. So that's at 26.7. So that would be negative 0.3. So that's kind of what residuals look like. It's just the distance those points are away from the line. So as we do a residual plot, I'm going to have to re-reference these residuals. And I'm going to do a bit of scrolling up and down. So if we look at here, if we look at when x is 0, what was the residual? Do we even have a data for that? We do. So when x is 0, like right, x is 0 down here, that residual was 0.2 up here, right? It was 0.2. How do I hit undo? I don't know. So at 0, the residual is 0.2. So that's my residual plot. Now let's look for 1. Let's look at 1. What were the residuals for 1? Well, let's go to our residual plot. At 1, our residual was 0. So our residual was 0 for 1. Now let's go look at 2. At 2, we had a couple residuals. We had a positive 0.3 and a negative 0.4. So at 2, I forgot it already. Positive 0.3, that'd be about here, and a negative 0.4. That'd be down here. That's the residuals at 2. Let's go to 3 now. Okay, now we're looking at 3. So at 3, there was a couple residuals. We had, there's one on the line, which gives us a residual of 0. And there was 1.3 below the line, so negative 0.3. So at 3, we had a residual of 0 and then a negative 0.3. At 4, again, there was 2 residuals. We had one that was on the line showing a residual of 0, and we had one that's a little bit above the line, 0.2 above the line, so a residual of positive 0.2. So at 4, we have a residual of 0 and a residual of positive 0.2. Okay, let's do 5. We're on to 5 now. At 5, there was just one residual of positive 0.1. So at 5, positive 0.1. And then last but not least, 6. There was 2 residuals on 6. We had a 0 residual because it was on the line, and we had another residual that showed a negative 0.3. So at 6, we have 0 residual and a negative 0.3. Okay, so that took some time, but that's how you make a residual plot. Now, here's the thing. It's a mess, right? It's just a bunch of dots kind of scattered up and down. You don't connect them or anything. It's just a residual plot. I mean, I don't even know how you would connect those dots. Some of them are vertically stacked on top of each other. This is what a residual plot looks like. It just looks like a mess. And it's supposed to look like a mess because you're supposed to be having, if you have like this, our x-axis right here, like you're supposed to be having like it above, below, above, below, above, below. Like you're supposed to have the residuals be, a little bit above it and then a little bit below, 0, positive residual, negative residual, positive residual, negative residual. That tells you this line makes sense, like that's the whole point. Like the line is supposed to cut through the data where you have like some positive residuals, some negative residuals kind of alternating. Like that's how the residual plot's supposed to look. It's supposed to look like this. That's how it's supposed to look. And hopefully the points are condensed because that means like it was a strong relationship. We're saying that those points are really condensed. So that means that like the best fit line went right through it. There's a strong relationship. It's not like spread out, like huge residual, another huge residual, huge residual, huge residual. Like that means that there's, either outliers or there wasn't a very strong relationship. And I hope that's making a little bit of sense. So why don't you try the residual plot on here and then maybe you can kind of see which one's the outlier just from looking at the scatter plot, hopefully, but the residual plot's going to make it a little bit more obvious which one is the outlier. So similar discussion that I try to just kind of have with you. Let me read this. So this is what residuals kind of tell us. It says the slope of the line and the residuals determine the size and strength of the correlation. A line with a positive slope indicates a positive correlation. A line with a negative slope indicates a negative correlation. That's pretty obvious, right? Positive slope, positive correlation, negative slope, negative correlation. Now here's in the bold is kind of like a thing that I was trying to get in your head. It says residuals with smaller absolute values, which is the distance from 0, like smaller absolute values, smaller numbers, indicate stronger correlations. Residuals with higher absolute values indicate weaker correlations. So in number 4, it says, which of these 2 residual plots indicates a stronger correlation? Well, let's look at them. Which ones have smaller absolute values? Which ones are closer to 0? Look at these residuals. Like which ones are more, spread out? Or which ones are, I guess, less spread out is the question I'm really asking. Like, don't you see in residual plot A, like the data is tighter, it's closer together? That means that this is a stronger correlation, residual plot A. Because the data is tighter, it's more compact. That means if you think of your best fit line, you don't need to draw this. But if you think your best fit line, our dots are close to it. Meanwhile, on B, still not bad, but the dots, the residuals are a little bit more spread out. See that? A little bit more spread out, the residuals bigger. So if we want a stronger correlation where there's less variation, residual plot A shows that. And I hope that makes a little sense. Okay, I'm going to do number 5 as well. I know I'm doing the majority of this, but residuals are kind of confusing. So number 5 says the comparison between the number of ounces in a food item and its calories for a particular fast food restaurant is given in the table below. The line of best fit for the data can be represented by y equals 50.8x plus 101.64. So there's a lot of blah, blah, blah there. But it gives you a table with food items and their residuals. And it even shows you the graph, right? Even shows you the graph. So, just so we understand the table, we got a hamburger, the total ounces was this, the calories is this, the residual is that. So really these residuals are probably what we're going to be looking at the most, but let's just get going here. Whoops. Okay. So A says, is there a positive or negative correlation between the number of ounces in the food and its calories? Positive. Of course, the more ounces in the food, the more ounces in the food, the more calories it's going to have. Look at the line. It's going up. It's a positive slope. There's a positive correlation. Don't overthink these. I mean, this is a lot of just analysis. Not much math here. It's positive. Based on the graph that has residuals, would you consider this a strong correlation, somewhat strong correlation, or weak correlation? Okay. Well, look at the graph. It looks like the data is pretty darn tight. Look at this. Look how tight that data is. But then these ones kind of have larger residuals. And you can kind of see that. Like, here are all our residuals, right? And like, that's a hefty residual there, 100. These ones are kind of large too. And I think that's what we're seeing with, over here, these points. Maybe I'll circle them in blue. These points here, I think these are those high residual points. So it's pretty strong, but I think some of those, it's not as strong. So I'm going to say this is a somewhat strong. Because this kind of indicates a pretty darn strong correlation, and negative 29.5, that's not terrible. Negative 4.8, not terrible in terms of correlation. There's some really tight data, but it's not incredibly strong. So I'm just gonna say somewhat strong. Now C says, would you consider any of these food items an outlier? If so, which one? Okay, so you see that when I circled the 102.3. I'm going to go ahead and I'm going to say that's the outlier because that residual is quite large. And let me erase some of this other stuff just so to not make this so messy. And if we look at this graph as a whole, sorry, I was trying to erase this all. This point here, that point, that is that grilled chicken sandwich. Because at 7.1360, like 7.1's here, 360, about here, that is that grilled chicken sandwich. So I'm going to say that that's the outlier, is that grilled chicken sandwich. Yes. Grilled chicken sandwich. Do you think this food item affects the judgment of the strength of correlation from question B? I think so. If this point wasn't here, if I just kind of cross that out, that point was not there. I would say this was, I might actually say this was just like a straight up strong correlation, not a somewhat strong. So I would say yes. Yes. It makes the correlation a little weaker. That's what I would say. Okay, so these residual questions are kind of strange, but really just use your common sense with some of this and try to work through it. Okay.